Dear students, in this class you will be studying atomic and ionic radii of transition elements. What is meant by ionic radii? So that means distance between the nucleus and the outermost electron is nothing but atomic radii. Means if this atom is in the ionic form, then the nucleus has some influence on its electronic cloud. Then the nucleus, how long the influence of nucleus and the electron will be there, that distance will be called as ionic radii. So we have seen this diagram in the previous semester. The atomic trend of atomic radii decreases along the period as the differentiating electrons entering to the same atomic orbital, whereas when we go down the group, atomic radii increases because of the addition of one more atomic orbital. Here we have a orbital, here we have a 3 orbital, here we have a 4 orbital. As we go down the group, each element will get extra 1 orbit. That's why the atomic radii increases down the group. When we go upwards in the group, atomic radii decreases because of the removal of one atomic orbital. This is the actual periodic trend of the atomic radii. Now we will be concentrating only on the d block elements. That's why we will see the atomic radii, how does it vary along the period. In the periodic table, atomic radii of d block elements is irregular. You can observe in this graph, that is for 3D series, scandium to manganese it is decreasing, manganese to nickel it is almost becoming constant, and then copper to zinc it is increasing. This is irregular in nature, which is decreasing and becoming constant, then again it is increasing. For yttrium, for the 4D series also, it is following the same trend as in the case of 3D. For the 5D series also, it is following the same trend as in the case of 3D. But when we go down the group, we expect that the atomic radii increases. When we go down the group 3D to 4D, the atomic radii increased. That is, it has been increased from 14 nanometer to 15 nanometer from 3D to 4D orbital, whereas from 4D series to 5D series it has not been changed. That means 4D and 5D series are having similar size because of the addition of lanthanoids. Here we have a 14 elements. That's why the atomic radii of 5D series will be same as in the case of 4D series. That is known as lanthanoid contraction. We will see this later when we are studying lanthanoids. So atomic radii will be irregular for the d block elements because of the two reasons. First one is increase in nuclear charge, that is known as effective nuclear charge. And the next reason is screening effect or shielding effect. We will understand these two terms in detail now. What is meant by effective nuclear charge and screening effect? Effective nuclear charge. To understand this, we will see this diagram once. We will be having a nucleus at the center which is filled with positive charges around which the electrons are distributed which are negatively charged. So there will be a attractive force between the electrons. These electrons are arranged in a different orbits, in a different layers. That's why different energy levels. So these different energy levels are placed at different distances. So when we are having two types of electrons, electrons which are in inner orbital are called inner electrons, inner electrons which are in the outer orbital are called as outer electrons. So the nucleus has the force of attraction between the inner electrons and also with the outer electrons. So outer electrons and inner electrons will be having repulsion because of the same charge, electron repulsion. So because of this electron repulsion, the outer electrons will not experience the nuclear charge of the nucleus effectively. The inner electrons are avoiding outer electrons by means of repulsive force. That's why outer electrons will not experience the nuclear charge completely. Outer electrons will experience less amount of nuclear charge when compared to inner electrons. So, the outer electrons will not experience the nuclear charge as the inner electrons experience. That means the net positive charge experienced by the outermost electrons is nothing but effective nuclear charge. That means if you want to understand this in a simple way, you observe this picture. Amitabh is a celebrity, he is at the center like nucleus. People around him are the electrons, which are the people are arranged in different distances from the nucleus. People who are very near to the Amitabh can take photograph, can talk to him very easily, whereas people who is standing away from the Amitabh not able to talk effectively with the Amitabh, like because of the repulsion between the people in between the Amitabh and the outermost person. Like this, the outer electrons can't be able to experience the positive charge of the nucleus completely. That's why amount in which the outer electrons are experiencing the positive charge of the nucleus is nothing but effective nuclear charge. That means the net positive charge experienced by the outermost electron in a multi-electron system is given by Z effective is equal to Z minus S, where Z is nothing but atomic number and S is nothing but screening constant, which is equal to the number of inner electrons. So, how does effective nuclear charge affect the atomic radii of d block elements? If when we are adding electrons to the atom, we will be adding one positive charge also, which will be concentrated at the nucleus. When we are removing electron, we will not remove the proton which is inside the nucleus. That's why there will be a more positive charge in the nucleus, which can attract less number of electrons when we are removing electron from the outer or valence electrons. So, when we are adding positive charge to the nucleus, which will be concentrated at the nucleus, which can attract the electrons of the valence shell more effectively. If effective nuclear charge is increasing, means there will be a more attractive force between the nucleus and the valence electrons. So there will be a more attractive force, means this nucleus can hold the outer shell electrons also very effectively, so that the size of the atoms decreases. If the effective nuclear charge is less, means the electrons which are not experiencing the nuclear charge effectively, so that they will be away from the nucleus, the size of the atoms increases. Here we have two cases. One is the higher Z effective value and lower Z effective value. If Z effective is more, means the inner electrons are less in number, then there will be a more attractive force between the nucleus and the outer electrons, because there will be a less repulsive force between the electron. That's why when the outer electrons are attracted towards the nucleus, there will be a minimum, or size will be minimum. In the similar way, Z effective will be minimum if the inner electrons are more, the S factor will become higher value, then Z effective will become lowered. So that means outer electron will experience the less nuclear charge, that is positive charge. They will be staying away from the nucleus. That's why size of the atom increases. Size increases or will be maximum. In this way, effective nuclear charge explains the irregular pattern of atomic radii in the case of d block elements. The next factor is screening effect. To understand this, watch this picture. Here we have a nucleus, here we have a inner electrons, and outer electrons. There will be attraction between the outer electron and inner nucleus, and there will be a repulsion between electron. Because of the electron repulsion, the inner electrons avoids or screens or shields the outer electrons from the nucleus, so that the outer electrons will experience lesser positive charge or nuclear charge. This phenomenon is known as the phenomenon of screening of outer electron from the nucleus by the inner electrons is known as screening effect. You can understand by this the same example. That means Amitabh Bachchan is a nucleus, whereas the people around him are electrons. People who is standing away is the outer electron. People who is standing in between outer electrons and the Amitabh are inner electron. If the people in between the Amitabh and the outer person increases, then last person can't be able to talk to Amitabh. That means people who are standing in between the outer person and the Amitabh are avoiding the outer person to talk to Amitabh. This effect is known as screening effect. The phenomenon in which the inner electrons shields the outer electrons so that they will not be affected by the nuclear charge. As we have known that the s orbital will shield more when compared to p orbital, because s orbital will be the outer electron in the case of d orbital, that is 4s, 5s, 6s. These are the outer orbitals. These shields more when compared to p, d and f, and f orbital will be shielded less when compared to d, p and s orbital. I hope you understand this screening effect. Avoiding of outer electron from the nucleus by the inner electron is nothing but screening effect. Now we need to apply this effect to the d block elements. As we have 3d orbital, d orbital and 4s orbital, 4d orbital and 5s orbital, 6d orbital and 5d orbital and 6s orbital. As we go down the group from 3d to 4d, 4d to 5d, there will be addition of one extra orbital down the group. That's why in the 3d series, there will be a less number of electrons when compared to 4d. That's why 4s will be shielded very less. And then 5s will be shielded more when compared to 4s orbital. In the similar way, 5d will shield the 6s electrons more effectively. That's why size increases down the group. So number of inner electron increases, screening effect increases with increase in the number of inner electrons. We will see here, from scandium to chromium, there will be a higher effective nuclear charge when compared to screening effect. So higher effective nuclear charge means inner electrons will be less. That's why nucleus will hold the outer electron tightly. That's why the radii decreases. From manganese to nickel, there will be an equal amount of effective nuclear charge and screening effect. That's why there will be a constant in atomic radii. From copper to zinc, there will be increase in the number of inner electrons. These inner electrons shield or screen the outer electrons more effectively, so that the screening effect increases. That's why atomic radii also increases. In the similar way, if you measure the atomic radii of 3D, 4D and 5D, you can observe here the atomic radii decreases from scandium to chromium. After manganese to nickel, there will be a constant, and copper to zinc has been increasing. In the 4D series, you can observe from yttrium to molybdenum it is decreasing, ruthenium to palladium it is almost similar, constant, and after that silver to cadmium it is increasing. Here you can observe from lanthanum to tungsten it is decreasing. After that osmium to palladium it is almost constant. Then after gold to mercury it is increasing. And you have to observe one more factor, that the 4D series and 5D series will be having similar atomic radii. This is because lanthanoid contraction, as I said before. Next, we will move on to ionic radii. Ionic radii means the influence of positive charge, nuclear charge to the outermost electrons in the ion. So this is also following the same trend as in the case of atomic radii, but ionic radii will be different for different oxidation states. Ionic radii decreases along the group. As we are removing electrons, there will be an increase in the number of protons, so that the effective nuclear charge increases. Effective nuclear charge increasing along the period. That's why the size of the ions of the +2 oxidation states of the transition elements decreases along the period, except from copper to zinc. This is for +2 oxidation state. Next, we will see the ionic radii of +3 oxidation state. That means, here you can see here for +3 oxidation state also, there will be a removal of 3 electrons, and the effective nuclear charge will be even more higher when compared to the +2 oxidation state. There will be a decrease in the ionic radii along the period. So you can observe here, it is decreasing along the period. And when we compare the ionic radii of +2 ions and +3 ions, metals with the +3 ions will be having higher effective nuclear charge when compared to M+2 ions. Higher the effective nuclear charge, smaller will be the ions. So that when we compare the M+3 ions and M+2 ions, you may observe titanium, which is having 76 nanometer. Here you can observe 9.9 picometer, that means 91 nanometer, which will be titanium +2 ions will be in larger size when compared to titanium +3 ion. That means +2 ions will be larger in size when compared to +3 ions. That means higher the oxidation state, higher will be the effective nuclear charge, smaller will be the ions.